Hello and welcome. Today I want to explain to you about the continuation of my experiment. So in my previous video, I already explained to you about how to convert from PyTorch file to onnx, and then in the second part, I explained to you about how to build a custom environment, train it, and how to design a reward and system, how to design reward and punishment system, and etc. And now we move to the, I think this is last part, we move to the where we want to implement this model to the real application, that is snake game. Okay, this is the script. And as you know, if you watch my first part of this project, I explained to you about using a webpack, right? But I found a more simple approach, that is using CDN. So I just need to import this and we can load the model. Yeah, this is the style. This is to display the board and the snake and the foot. And this is the body. This is the game board. Okay, just that. And then the rest is JavaScript. Okay, now how the flow of this script. Okay, here first we run this init model, and as you know, I already show you about the init model in here. So here we load the model, and then the second is init. Init is, let's see, init is here. We create a snake. The snake is like this. This is step by step. So as you can see here, we create a snake with 3 units long, and as you know, this is the same with the in the snake game environment that we built in Python. And then as you can see here, the coordinate is also same. And here, and as you can see here, we using 2 array. The first array is a array for the div or for the display, and the second array is the value coordinate of the snake. And here we create foot. Create foot is just, in this function we just pop up the foot randomly in the board. As you can see here, we also save the coordinate of the foot in some variable. And the step 3 is here. So this is the function that we loop, that we run forever, and the interval is in here. Okay, as you can see here, first we do process model, and then we do all of this. And maybe you ask why we do this. So as you know, in JavaScript, the function that using then is a asynchronous function, right? Let's move to the process model. Here, the asynchronous function. So here, why we using asynchronous function? Because when we want to predict, as you can see here, when we want to predict, because the run function in session here is a asynchronous function too, we must using a wait. And when we using a wait, that means the function that loaded must be asynchronous too. So that's why we do that. Okay, I will explain step by step of process model function here. So as you know, same as in the Python environment, here we collect the observation. So here we collect the coordinate of the foot in y and x coordinate. And as you can see here, we divide it by 20. Why? Because in this environment, the unit is 20, so to match the scale between the environment in HTML and in the Python, we must divide it by 20. And then in here, same with the Python control part, we also measure the distance between head snake and the boundary or the tail. This is the same step. And in here, this is the coordinate of head snake. And then we collect it in the one variable. And then same with the Python, we also normalize using 25 because the game board in here and in the Python is 25, right? And then after that, here, this is the interesting part. Here we init array of float 32, and then after that, same with the Pythons. As you can see here, if we using this module or this library, we also using tensor. And how to build a tensor in this library or the library of onnx is using this function. And this is the type. This is our variable that contain the data, and this is the shape that we want. And also, this is the variable that contain our input because we name the input for our actor critic as input, so we must type input in here. And then we feed it to the model and we get the action. And then that action will be fed to this function, change direction board. Okay, let's move to that. And here, the change direction board it's like change the direction movement of the snake. Oh yeah, so in here, we translate the action to the real movement. And the interesting part is here. Actually, this is when I build the script, this is the hardest part because, yeah, now it looks simple, but when I build this, make me confused. But because my board is so stupid, it's not like in the Python. So in here, we must the up and down in here is upside down because in here the case up and down, the logic is upside down too. In here, as you can see here, when we using up, the value is decreased, but when we using down, the value is increased. So that's why in here we must exchange both of them. Okay, now after we doing the process model, we move to here, and in here we want to get the coordinate of the head snake. And in here, I already explained about this. This is how we move. And in here we check for the collision with walls, and here the collision with tail. And then in here, this is also the part where we move the snake. This is the part where we check whether the snake is already hit the foot or hit the target or not. So in here, when the snake is hit the target, it remove the foot and then it create it again. And then if the snake is not hit the foot, it just move like usual. And this is just a catch. And yeah, this is the game over function. This is called when we doing a collision with walls or tail. So we reset the interval and then alert game over, and then reset the board, reset the snake board, and after that we doing a unit. So we start from the beginning, and I think that's all. Now let's do the application. Okay, let's play it. This is not played, we just watch the AI play. Oh, there's some lag, and as you can see here, the AI is good. It's play as good as in the Python environment. and it's game over. It's game over because it's hit the tail, and I think the Snake AI can be more smart if we resume the model training. And yeah, maybe in the next video or later I will try to experiment to train this a little advanced Snake AI so it will be play more smart than this. Okay, I think this is enough. Thank you for watching. Bye.